On this video, we're going to explain temperature increase or decrease and state change in terms of the kinetic molecular theory. Then we're going to do some end of chapter example problems. Temperature of a substance is directly proportional to the average kinetic energy of the particles. The definition of temperature is that it's a measure of the average kinetic energy of the particles. So if a substance is heated, the particles gain more energy, they move faster, and therefore their kinetic energy increases. You should know this. You should know what happens when you increase temperature, what happens to the kinetic energy. State change. If the particles have gained sufficient energy, they can overcome the intermolecular forces of attraction between them and move further apart. Because remember, when we explained solids, liquids, and gases in terms of the kinetic molecular theory, we did mention that there are repulsion and attraction forces between the particles in solids and liquids and gases, but they are stronger in solids. So if you heat a substance, the particles would gain sufficient energy to overcome those forces between the particles of the substance, and then they can move further apart. That's why you get state changes. And when you cool a substance or when you decrease temperature, what will happen is that the particles will lose energy, and then the intermolecular forces will become even stronger. The position of the particles relative to each other changes during a state change, and also the potential energy changes, but the kinetic energy remains constant. You should know that the energy absorbed or released during a state change is latent heat. So let us do some end of chapter example problems. Question 1 is about Brownian motion. You should explain what Brownian motion is and what is used to verify. So this is the definition of the Brownian motion. It is the random movement of the microscopic particles of a substance due to the collisions of particles with the surrounding air or liquid. What it is used to verify: it's used to verify that matter is composed of separate small particles that move continuously. Hope you're clear on that. Okay, and then we move on to question 2, which is on kinetic energy. You should explain why the metal lid of a bottle or jar unscrews more easily after holding it in boiling water for a few minutes. The reason for this is that when the metal is heated, the particles or metal atoms acquire more kinetic energy and move more vigorously. In this way, they move a little apart and the lid expands so that it becomes easier to unscrew. So they gain more kinetic energy. Just as I told you that when you increase temperature, the particles gain enough kinetic energy to overcome any intermolecular forces. We move on to question 3. We're determining the states given melting and boiling points. We did an example like this, but now we are working with compounds A to D. We don't know their names, and our room temperature is 25 degrees Celsius. So remember, in our previous example, we worked with a temperature of 23 degrees Celsius, but now we're working with a temperature of 25 degrees Celsius. So A has a melting point of -218 and a boiling point of -183. So the temperature of 25 degrees Celsius is higher than the boiling point, which means that A is in its gaseous state. Remember, you need to know what happens when the temperature is greater than the boiling point, what happens when the temperature is between the melting point and the boiling point, what happens when the temperature is lower than the melting point. And then B has a melting point of 0 and a boiling point of 100. 25 degrees Celsius is between these two temperatures. So 25 degrees is greater than the melting point but lesser than the boiling point, which means that B is in its liquid state. And then C has a melting point of 51 and a boiling point of 320 degrees Celsius. And 25 degrees Celsius is lesser than the melting point, which means that C is in its solid state. Then D has a melting point of -20 and a boiling point of 40. Again, 25 degrees Celsius is between these two temperatures. So 25 degrees Celsius is greater than -20 degrees Celsius, but it is lesser than 40 degrees Celsius, telling us that D is in its liquid state. Let's move on to question 11 about cooling and heating curve. So question 11 is basically about a cooling curve. So there's a cooling curve from a solid to a liquid, not liquid to solid, but solid to liquid, for a substance called naphthalene. And you should answer the following questions. I hope you can clearly see the picture. On the y-axis we have temperature in degrees Celsius. On the x-axis we have time in seconds. Then our temperature starts from 65, 70, 75, 80, 85, 90, and our time starts at 1 second, 2, 3, 4, up to 18. So question 1, what is the melting point in degrees Celsius for naphthalene? So when you look at your graph, you're gonna look for where the temperature stays constant, and then that's how you know that is your melting point, because you know that state changes occur where temperature stays constant. So you're going to look for the temperature where temperature is constant, and that will be 80 degrees Celsius. So that's 80 degrees Celsius. And then you should explain how you know this from the graph. I already told you the answer, if you think about it, because I did say that you look for where your temperature stays constant, and then you know that that is where your melting point is. So you know, because during this time the temperature doesn't change, and so the graph levels out for this period. Now you should use the kinetic molecular theory to explain why the graph is flat during this time from 4 to 11 seconds. So during the first change, heat is emitted into the environment, and then what happens when heat is emitted into the environment? The kinetic energy of the particles and the temperature of the substances remains constant. The potential energy decreases, but it is not shown on the thermometer, so we're not really gonna talk about it. We just need to talk about the kinetic energy, which is shown on the thermometer. Okay, so that is it for this video. On the next video, we're gonna start on a new chapter, the atom.